Hello everyone, this is a problem from Griffith second edition quantum mechanics. Here find expectation of x, expectation of p, x square expectation, p square expectation and kinetic energy T expectation for the nth stationary state of the harmonic oscillator and check that the uncertainty principle is satisfied. So first of all, x for harmonic oscillator, in operator form we have H cross by 2 m omega a plus a minus, and for momentum we have iota under root H cross m omega by 2, and we have here E plus minus E minus, and for x square we have H cross by 2 m omega, right? And here we will be having E plus square, E minus square plus E plus E minus plus A minus A plus. For p square we will be having minus H cross m omega by 2, A plus square plus A minus square. Here will be A plus A minus A plus A plus, right? Now for expectation of x, we can write for nth state Brian x operating on cat n. So this will be getting by replacing x as H cross 2 m omega, and then we have A plus A minus n, right? So when A plus operator on n and A minus operator on n, we will be getting A plus operating on n, we will be getting under root n plus 1. This n will be incremented by 1 and the state will be n plus 1. Similarly, for A minus operating on n, it will be under root n, but the state will be n minus 1. So we will be doing here the same operation, H cross by 2 m omega. So when we will be operating A plus on n, we will be getting something n plus 1. So n plus 1, inner product of n and n plus 1 will be 0. Similarly, when A minus operating on n, we will be getting a state cat n minus 1, and this cat n minus 1 over inner product of n with n minus 1 will be 0. So ultimately this will be 0. Similarly, we can see for p, the operator here A plus and A minus will be same. So in case of momentum operator, expectation value will also be 0. Now comes x square. So this will be n x square, and now we have x square is H cross by 2 m omega, and then we have n A plus square plus A minus square plus A plus A minus plus A minus A plus operating on cat n. So similarly, we can see it's here the operator is A plus square. When this operate on cat n, so it will be like incremented by 1. When A plus operate on n, it will be giving something n plus 1. So when we operate a plus a once more again to n plus 1, it will be n plus 2. the n plus 2 inner product of n and n plus 2 will be 0. So this will be 0. A minus will also be 0 because it will be n minus 1 and then n minus 2. So inner product of n minus 1 or sorry n minus 2 with n will be 0. Fine. So for these two terms will be 0. So next we have n a plus a minus a plus operating on n. So now we will see here when a minus operator on n, it will be giving under root n and the state will be n minus 1, right? State will be n minus 1. So we will write a plus here and it will be n minus 1, right? Similarly, plus n will break these two. So Brian, and now a plus will be operating on n, we will be getting under root n plus 1, and then we have a minus operating on n. This will be n plus 1, right? So here when a plus operator on n plus 1, this term will be getting under root n. So under root n and n will be getting n. One thing we are missing here is a is crossed by 2m omega. Similarly here will be a is crossed by 2m omega. So now a is crossed by 2m omega. So here we will be getting a plus operating on n minus 1 will be getting under root n, then cat n. So inner product with these will be 1. So we will be left with under root n square. Similarly for this we are having a minus n plus 1. So n plus 1 will return the value under root n plus 1. So this will also be n plus 1 whole square, and then we will be left with cat n. So inner product of n with n will be 1. So this will exist and you will be getting h cross by 2m omega 2n plus 1. Similarly we will be finding for p square. We have what? Minus h cross m omega by 2 Brian a plus square plus a minus square minus a minus a plus minus a plus a minus. Similarly for these two we will be getting 0, as we are getting 0 in this x square expectation. So here is minus and then this is also minus. So this minus and this minus will get cancelled out and we will be left with h cross by m omega by 2, right? Now similarly a minus a plus a minus. So here we are having the same thing. So we will be getting here also 2n plus 1, right? So now we are left with expectation value of t. So expectation of value of t is given by expectation value of p square by 2m. So this is 1 by 2m multiplied by expectation of p square, that is h cross by m omega by 2n plus 1. M out cancel, will be left with h cross omega by 2 n plus half. Now we are left with uncertainty principle. So for uncertainty principle we have to find the standard deviation, that is sigma x under root x square minus x. So this is 0 and x square we have this. So under root h cross by 2 m omega 2n plus 1 right, and sigma p sorry. So expectation of p is 0, so we'll be left with p square. So this is under root this h cross m omega by 2n plus 1. So now therefore sigma x into sigma p h cross by 2m omega 2n plus 1 multiplied by h cross m omega by 2n plus 1. So we'll be left with 2n plus 1, and in under root we can cancel m and m as well as omega. So we'll be left with h cross by 2 or n plus half h cross, which is greater than h cross by 2. So our uncertainty principle is satisfied. Thank you so much.